Students, welcome back to Chemical Kinetics. In this module, we are going to see examples on representation of rate of reaction. So far, we have understood how to represent rate of reaction graphically and with the help of equations. Now, let us see some examples on it. Consider this reaction, decomposition of PCl5, which produces PCl3 and chlorine. If I were to write an equation which equates the rate of reaction with respect to PCl5, PCl3 and Cl2, it will look something like this. Rate of the reaction is equal to minus delta concentration of PCl5 upon delta T. Minus because PCl5 is a reactant. So in terms of PCl5, I will have to add a negative sign. In terms of PCl3, since it is a product, I can say that the rate is equal to plus because as I just said, PCl3 is a product, its concentration will increase with time. So it will be delta concentration of PCl3 upon delta T. Also in terms of chlorine, it will be plus delta concentration of chlorine upon delta T. This is just like the definition of rate of reaction that we have seen in the earlier modules. Now here, if you observe carefully, when one molecule of PCl5 reacts, one molecule each of PCl3 and Cl2 will be formed, which means that the rate of decomposition of PCl5 is equal to the rate of formation of PCl3 and Cl2. Isn't it easy, my friends? Let's take another example. Now, this example will be slightly different from the earlier one, but let's take a look at it. N2 plus 3H2 produces 2NH3. Formation of ammonia is what we are talking about. Now here, this reaction is slightly different from the earlier one. You've got some stoichiometric coefficients over here. Earlier, the stoichiometric coefficients were 1. The rate of reaction, the equation in which you write it, will remain the same, but for a small change. Wherever you have a stoichiometric coefficient, just multiply that term by its reciprocal. Let's understand with the help of this example. Here, in terms of nitrogen, the rate will be minus delta concentration of nitrogen upon delta T. This is because nitrogen is decreasing with time. It's getting consumed. In terms of hydrogen, however, I can say minus 1 by 3. Why minus? Because hydrogen is a reactant. It will decrease with time. And 1 by 3 because 3 is the stoichiometric coefficient. So just multiply by its reciprocal. Rest all remains the same. Delta concentration of H2 upon delta T. Same goes for ammonia. Here the rate of reaction will be plus because ammonia is a product. So 1 by 2. Rest everything remains the same into delta concentration of NH3 upon delta T. So essentially what is happening here is I am comparing the rate of reaction of nitrogen with respect to hydrogen and ammonia. And it makes a lot of sense because when one molecule of nitrogen reacts, 3 molecules of hydrogen react, which means hydrogen is reacting thrice as fast as nitrogen. Or I can say that nitrogen is reacting at 1/3 the speed of hydrogen. Take into account this small little reaction that you can see here. Try and pause the video and write this equation yourself. The answer that you will get will be rate of the reaction is equal to minus 1 by 5 into delta concentration of Br minus upon delta T, which is equal to minus delta concentration of BrO3 minus upon delta T. The stoichiometric coefficient in this case was 1. In terms of H plus, I can say that minus 1 by 6 delta concentration of H plus by delta T. In terms of Br2, which is a product, now I can say that it is equal to 1 by 3 with a positive sign into delta concentration of Br2 upon delta T. And in terms of water, I can say that the rate is equal to 1 by 3 into delta concentration of H2O upon delta T. Isn't it easy, my friends, writing the rate of reaction in terms of all the reactants and all the products? That's it for this module. See you in the next module. Till then, thank you.